Hey, this is Mrs. Davis. This is AP Computer Science, and we are in Lesson 7.3, and this is the second video, and we're talking about binary searches. And so we're going to walk through a binary search so you can see. And you're going to have to know how to do this because you're going to have to be able to say how many times something it took to find it in a binary search. So we're going to do the code. Let's use, for this one, let's use the code that I wrote, that the +1 and -1. Now in your homework, they have the one where it doesn't have the +1, -1. So just walk through that algorithm, and then it introduces the algorithm that does the +1, -1, and then asks you to do it. So we're just going to start that way in the notes. So let's look at this and see that it's sorted 2, 3, 6, 10, 25. And they want us to find the number 10. Okay, so here's what you do. You're going to get, and I'll make like a little table of how many times we try. So here's the first try. Okay, first of all, let's get our indexes because that's what you have to use for these. So we got 0 through 8. So you take the 0 and the 8, the two indexes, the low index is 0 and the high index is 8. And so you would find the average of those. So I would be 8 divided by 2 is 4. So then it looks at I, so it's going to say, what is I? I is equal to, if you look at 4, 13. So then it says that 13 is greater, so 13 is greater than 10. So that means 13 becomes my new high. But actually, since we're doing the -1 and +1, I can make 10 well, no, I'm sorry. 13 is greater than 10, so I make 3, 4. It was at 4, right? Doesn't help when I'm not doing this right for you. Sorry. It was at 4. That was the middle. And so now it's going to look at I -1. So that was the first iteration. Second iteration is low is still 0 and high now is 3. Because 4 was I and then it did I -1. So I equals I -1. So we have low of 0 and high of 3, okay? And so then we add those together, and so I is 3 divided by 2, which is 1. So then I of 1, I'm just putting the I in the brackets. I of 1 is 3, and we're looking for 10, so 3 is less than 10. So our new low gets assigned where our I was, right here. Our I was 3, right, and 0. And so our low, let's see, 3 is less than 10. Yeah. So our low becomes 3, where 3 was +1. So our low becomes 2. So we go down 1. So low becomes I -1. Okay. Hang on. It should be, I had an I of 1, right? And this is the low now. So it's I +1. Okay, so my low is now this guy. Here's my low. So now I'm looking from here to here. Okay, so the third time around, my low is 2. I was 1, so my low is 2, and my high is still 3. So 2 plus 3 makes 5 divided by 2, which is 2. Okay, so the I value at index 2 is 6. It doesn't equal 6. 6 isn't 10. Okay? 6 is less than 10. And so the low becomes one more than I had. So the low becomes 3. 2 plus 1 is 3. So the fourth time, I have the low as 3 and the high as 3. Together, that would be 6 divided by 2, making I 3. And then we look at I of, if I is 3, that would be 10, and we have a match. So it took 4 times. So we'll walk through a few more of those in some more examples, but I just wanted to show you how to do that. So let's see if I can do it without making the chart on some other ones. But for the first few times through, you probably should make a chart like I did and figure out what's low, what's high, divide it by. So just kind of follow the algorithm. So how many iterations did it take to find the number 10 with the binary search? Well, it took us 4 iterations. How many iterations would this take with a linear search? Well, what's funny is it would be the same amount, because it would look here to 1, 2, 3, 4, so it would still take 4. Now, that just happened to be because, I have a small number of items, and it happened to be on the lower side. If I was looking for, 23, it would be higher for the linear. So, for the following, I want you to determine which situation would be better for a linear search or a binary search. Right? So, you're thinking about the size, you're thinking about the order. So, the very first one says an ordered list of numbers. So, if it's an ordered list of numbers, it's in sorted order, and it will binary is always most of the time going to be faster if they don't tell you how many numbers there are in there. An unordered list of numbers, you have to use linear, because you can't use binary if it's not sorted. So here at number 3, you have an ordered list of numbers where the number you're looking for was the first element. So this would be linear, still would be linear better. You wouldn't know that ahead of time, but that's what would happen. An ordered list of numbers where the number you're looking for was the middle element. So this would be binary, because that would be the first one you'd find. You would be like, one time, I found it the first time through. And 5, an ordered list of numbers where the number you were looking for was the last element. Okay, and this would definitely still be binary, because it's going to cut it in half and cut it in half. So if I had to do a linear search, I'd have to go through each one of these. But if I do a binary search, I start here, and then the next one would be here, and then the next one would be here, and then the next one would be here. So you can see it's going to be less than looking through each one. And if you have a very large data set, you're going to try to do a binary search, and it would even probably be beneficial if it's very large to sort it and take the time to sort it and then do your search. So again, sorting comes next, but we are going to just realize that we have to have it sorted. That's all that really matters for this binary. So note that the binary search for an array list works the same with a few modifications similar to what we did for the linear search. So if we go back and we look at our code, or our algorithm, and we put it into an array list, let's see what we get. So we're going to do binary search code, and we're going to do it on, actually, we're going to do it with arrays, because the AP exam, most questions involved in the binary search only involve arrays. So you can still figure it out from array lists, but the one you should really understand would probably be the arrays. All right, so we're going to write the binary search code. And so you should be able to reproduce this and understand it. So we have public, static. We're going to return an int, so we're going to say where the middle one is, okay? And then we call this a binary search. That's the name of the method. And we have to give it the number we're looking for, and then we're going to use an integer array called ARR. All right? So remember what we did. The first thing we did was we put low as the first index. So low, we'll make a new variable. Low is equal to 0. That's always going to be the first index. And int high will be the last index. So that's going to be ARR.length minus 1. So we have made low and high. And so now we're going to keep doing this until we get a match. So we're going to have a while loop, and we don't know how many times it will take. So that's why we use a while loop, right? While low is less than or equal to high. Okay? Because when they meet each other, right? So that's when they stop. When you get all the way and you have 5 and you have pointing to this with low and pointing to this with high, then you're done. Okay? So you're done, and that falls out of the loop. So we would say that while low is less than or equal to high, we're going to find the middle. So we're going to be changing middle each time. That's why we do it inside the loop. Middle equals low plus high. We added the two together, remember, and then we divided by 2. So that's the middle guy. Then we check the middle guy. If ARR.middle equals num, so we're just checking, hey, did I get the right one? Is this middle one the right one? And if it is, we're going to return middle, the index that you found it at. If it's not, we're going to see if it's greater than num. If ARR of middle is greater than num, so we have to change high to be middle. That means that it was, let's see, it's easier if I put like, if I have 2, 5, 7, 9. All right, if ARR.middle, and I'm trying to find, say, I don't know, let me give one more number. I'm trying to find like 9, okay? So first I would cut it in half, and then if the one I find is greater than num, so say I found, it's not, but say I found 10, then I would put the middle to be high, minus 1. So I just changed the index to be 1 less. And then if it's not greater than num, that means it must be less than num. So else low equals middle plus 1. And then if it never found it in the whole while loop, we're going to return -1. And then we close our method out. All right, so you should be able to understand this and think through this. Okay, I'll stop the video here and then we'll go on.